but there's definitely a lot to think about there. So the next talk is from Bernardo Alves Furtado from IPEA in Brazil. I've had the pleasure to work with Bernardo on a couple of different things, and he always has some interesting insights into how he's actually using agent-based modeling in governmental policy. So without further ado, take it away, Bernardo.
Okay, thank you, Bill. Good afternoon, good morning, everyone. It's a pleasure to be here. I went to Washington last year, and it was really a good conference, good workshop. And from last year to today, I've worked a lot on my next model. At the time, I presented something called Policy Space, and now I took this year and I worked a lot on Policy Space 2, which is the same model, but with more complexity, some more markets. And like Bill said, my orientation is policy. I work close with the federal government, but we have seen how municipalities and how states have a hard time to shift from the science and decide how to make a decision. But mostly I'm worried about how the prognostics, yes? If you go to a meeting, somebody has a great idea, that's excellent, all right, let's sit on the table. And then it becomes a policy really quickly and really fast. But then, can we anticipate a little bit? Can you take a look on what are going to be the effects? And usually the effects, they are very one-sided and partial. So part of my idea working of policy space is the idea that if you apply a policy on one area of society, you can get results on other areas and you have a global general understanding of the effects of the policy. So I'm going to present machine learning simulates agent-based model towards policy making. I'm going to have two parts in the discussion. First is very illustrative, just some pictures, but it helped me think a little bit, and they were very much motivated by the email that Bill sent us with very good questions about what are the foundations of IGSS. And then I'm going to get more concrete and show you the exercise I've been doing with Policy Space 2. Actually, I just formatted this for this conference. Policy Space 2 is being reviewed, but I think there is some room for us to learn something here. Okay, so my first thinking when I got the email from Bill was this. There might be, because people in agent-based model nowadays, they try to predict, like Josh said, and they don't try to explain so much. But when they try to predict in economics, they get the good idea of if you're predicting, you're doing it right. Bruce Edmonds has these all purposes of what your ABM is doing and what do you want your ABM to do. But then when you're describing social phenomena, if you fit a pattern, then you can say that your ABM is good, you have validated it, and then you're going to use it for prognostics. But in social phenomena, we're living it through here in Brazil, in the US, and it's sometimes difficult even to describe what is the phenomenon now, what is going on, which indicators can you characterize what's going on now. If you can't describe it today, imagine in the future, right? We are talking about getting the trajectory and the rules and understanding how you can get from A to B, but there might have been another A or another B, and the trajectory may have happened by chance. So that's why I think social sciences is so much different from physics, yes? If we repeat history with the same initial state of things, we are not guaranteed that it's going to replicate the same trajectory. Okay, so machine learning help us in the sense of artificial intelligence, that is the goal of the seminar, in the sense that it's much easier for us to expand this space of possible trajectories. So if we think about initial social phenomena, that it was badly described or that missed a little bit here in the beginning, you can generate a space of possible trajectories and get to an end that it might be around the end that you expect, or no, that it can have a different trajectories. But then we are talking all day today about how can we curb and bound this space of trajectories. And then what I was thinking is that maybe if we have a normative idea, if what we want is policy, then we might just have a way of bounding it. So the question that it's still motivational, and then I'll get on to the empirical part, is independent of the observed real or possible trajectories that might have happened, is there a space of parameters and rules? Here, when I talk about parameters, in policy space, rules are parameters as well, 1 or 0, true or false. This rule is in effect, or this rule is not considered. Would there be policy alternatives that are socially optimal? Or if you can't say, of course, we can debate what's optimal, but can you get some policy results that are superior despite that you cannot describe completely your beginning, your ending, and your trajectories, right? And then that would be our blue line here in this illustrative figure, right? If we had all this phenomena, we can describe it about the right, then we can generate some machine learning and some space of trajectories. Can we have a superior bound here that is better for society? And here I'm thinking not in terms of a scientist, but in terms of a policymaker. Can we help the policymaker, right? And then that's just the illustrative part, and I'm going to get on what I'm actually trying to do with that. Like I said, I just have a policy space 2. It's under review. I have a preprint of that, but I have written a book in Portuguese here at my institute, and it's going reviewed. I got 3 reviewers. I got 2 reviewers from the journal, and then I'm improving the model, basically the description of the model. But the model is very comprehensive in the sense that we have a labor market, we have a real estate market, we have a rental market, we have a simple credit market, we have a goods market, we have the municipalities, we have the empirical details, we have demographics, we have immigration, we have divorce, marriage, children, inheritance. There is a lot of information on policy space too. And it's very empirical because most of the data is from census and households. There is no data input in the model about real estate, for example, but we try to validate the model with real data of real estate. And when I was building the model, because we know, you all know, we have faced all this criticism. My institute is basically economics house. And then I have a lot of rules that I test. Okay, I have this idea, and we are going to negotiate the market, and to sophisticate the negotiation, there is an upper limit to the discount that the seller will give, for example. And I have all these rules. And then what I did is we can test the rules and play with the rules or without the rules. And then I ran manually, of course, 5,573 runs of this model, because I wanted to have a lot of sensitivity analysis. I wanted to test. We have 46 different metropolitan areas. All of them I wanted to test and see, oh, is this result just for one region? Or does it maintain in another region? And specifically, I was testing the policy. I tested the policy results for 5 different regions. I'm going to show the result. And we get to the idea that the model is robust because these results of policy, they remain constant despite the totally different areas, totally different parameters and everything. So I have this model that is supposedly built on literature, that is supposedly built on empirical data, that is constrained by my idea of what a model is and the opinion of seminars and feedback of people. And then we have all these configurations for these parameters of 5,000 runs, and we have 66 different indicators for the results. So this idea I developed earlier on last year, but now I could actually implement it. And then could we have a larger, more flexible sensitivity analysis with 1 million runs or 2 million, because it doesn't take that long. So the idea was that I could make that space of trajectories denser and learn a little bit. Of course, when I do the sensitivity analysis manually, I have one-by-one parameter. I'd also have 2 or 3 parameters together. But then it becomes a little bit difficult to understand what's going on, because if you don't know which parameters are contributing for the change in the results by how much. So when I do this 1 million runs, what I want to check the robustness of results. My policy recommendation, does it stand this trial of 1 million different configurations? Like I said, can we identify a superior dominant dense policy space that will help with my policy normative framework? And then for IGSS specifically, I'm trying I haven't come to a conclusion to that, but I'm wondering about, is it possible to test a rule that is not in the model? I tried doing that with zeros and ones, and imagine there was a rule that wasn't there. I'm still working with that. I can work on a rule that I use past data, and then I check to see if the omitted rule in my model should be there or should not be there. So procedures are kind of simple. You just read and organize all these folders and all these 5,000 runs, and you organize the parameters. For example, some of the parameters, they don't change much. Some of the parameters I evaluate more times because I was more interested in the results. For example, almost 90% of my sample is about Brasilia. And then some of the cities I ran just 20 times. So it might not be enough to differentiate among the 46 metropolitan regions. And then you get the 66 indicators of output of the model: GDP, PIB, inflation, families' wealth, unemployment, firms' profit, number of houses constructed, price of the houses, everything of the model, gather those results. And then this is a point that is we instructed, right? What is the optimal target that we want? And then I designed it like that. We have output for production and we have output for Gini coefficient. And Gini coefficient is measured by the amount of wealth, and it's like they use in the economics, permanent income, and includes the wealth of the agents, right? And also the wage and the past history of wages. So can we get a socially optimal target that it's the best 1/4 of production and the best 1/4 of inequality, right? And then I have more possibilities. I'm going to work on that. I could use other info. Oh, no, I don't care about inequality because I am from Sweden. I care about unemployment. And then I can design a different social optimal. Or inflation is a problem. I work for the Fed. I want to control the prices and everything, right? So there's a lot of possibilities. No, I want houses to be affordable. I have this indicator as well. And then you train the machine learning with this target that I have decided. And when I generate the sample of 1 million possible configurations, I make the variation of the parameters much larger than what I actually tested, right? But I truncate that because it depends on the parameter, right? For example, I cannot make the agents infinitely productive. Or when I'm talking about the rules, I just have true or false, right? Although in Python, you can implement a rule that is 0 is false, and then 1 is true, but you can also have 2 and 3 and 4. Like how much neighborhoods influence my real estate uses this kind of rules that is a growing ordering, right? And then you get this machine learning that you trained, and you fit the parameters, you compare the relative results. Okay, so some preliminary results. What do I have? It seems that it's much more precise than the one that I did hand-to-hand. Results were not completely different because I have run 5,900 manual analysis, so the model is kind of well calibrated, considering 46 different regions, of course. But it seems that the machine learning is a bit more precise, and it captures some differences that I hadn't noticed before. Of course, for the policy analysis, I did a whole bunch of plots, and I knew the results of the trajectories, and I knew which policy was better. But then there were some nuances, some part of the results that I hadn't been identified. For example, I'm going to talk a little bit about the policies, and you're going to understand that I have two parameters, which is one policy quantile and one policy days. Policy quantile is how I determine which households are poor so that they're going to be eligible for the policy, right? And in this case, I ran for 20% of the bottom poor people. In Brazil, for you to have an idea, about 45% of the families, households, do not have enough money to buy a proper, adequate house. So we are a poor country, as you know that. But for the policy, I chose only two things. The family, if it's a housing policy, we need to be, you can't have a house already, and you need to be in the 20% bottom decile of poverty. However, I tested in my sensitivity analysis with 0.1, 10%, or 0.3, 30%, but I didn't test with 19.5 or 20.5. And then with the machine learning, I learned that if I reduce the policy quantile a little bit on this parameter specifically, the results would be better, would be more optimal in terms of social output. And this is what I'm looking for, right? I'm not only talking about understanding the mechanisms, understanding what's policy is better for prognostics, but also it might be useful for me to pinpoint, oh, this parameter for the actual policy should be 18.7, which might be impossible to do by hand, right? Also, policy days refers to, you see that all the parameters, they have a meaning, right? They have a construction. So it's not just A, B, and C, and beta. They make sense because we know what the model does. We built the model, right? And then policy days, for example, is the time of period that I look backwards to see when the family registered for eligibility to the policy, right? I consider the full year, for example. I consider, like I said, in the sensitivity analysis, 6 months, but should I have considered 7 or 8 or 9 months? So the machine learning, I think, will help with that. So I used it like my 6,000 sample, and I separated for test and the train, and the test got about 20% of the number, and I got a very good random for. I'm not an expert in machine learning. I did some very basic exercise. I want to do it further, but a simple random forest classifier got me a very high score of 9842. And then the confusion matrix, how did it work? Most of the non-optimal results were correct, 1,148. And in the optimal results, I got a little bit less. 19 were classified as optimal, but were not actually optimal. Okay, and then the final results, and I'm about to end, right? So the 4 policies that I tested, remember in the beginning, I told you about having a housing specific policy, which the reviewer didn't like very much, because I also contrast and compare with a monetary aid, which is a family household policy, not exactly a housing from the urban department policy, right? So I tested giving a house to the household, no policy at all, of course, provide a rental voucher to pay for the house for 24 months, and a monetary aid that I get the amount of money that I'm distributing and I just give to the households, they do what they want. And all of this is in the endogenous, right? Because I have a fiscal system, the municipalities collect, spatially collect 5 different taxes, and then they use a percentage of this to implement the policy. So it doesn't come from exterior grant from the federal government, for example. It's the municipalities themselves that apply the money. And I confirmed my plot analysis. Yeah, I knew that the housing is the worst policy possible, and the monetary aid is the most policy, the best policy by far and large, right? Rental voucher is close to monetary aid. So if you are from the urban department, then you should go with rental vouchers. If you are a generic politician, then you should go for the monetary aid. And if you are from a construction firm, you might go for the housing, because in this example, the construction firms get a lot of money. And one result I did not anticipate was this, right? I had all the metropolitan regions, and the only contribution of them to the model is their structure, right? It's almost like the description, especially detailed description of households, years of study, size of the household, location in space. So this is structure of the given metropolitan areas in 2010. And what I learned from this result is that it seems that from the 46 metropolitan regions, some of them are more fit to an optimal case, right? And as you can see, São Paulo is not here, right? São Paulo and Rio de Janeiro are the power force of Brazil, but they're not here. All of this, for you who unfortunately haven't visited us yet, haven't been to Brasilia, to my office after the pandemics, they are all middle-tired cities, right? Belo Horizonte is big, but it's not the most, the largest. Fortaleza up the northeast, they are all middle-sized cities with some kind of innovation, of a biology sector, of entrepreneurship, of self-sustained diversity, like New York, for example, right? And this is something that I learned, right? Brasilia, we know it's very unequal because you have people like me who are employed by the federal service and get a high salary, and you have migrants from the Northeast who are very poor. So the inequality here in Brasilia is very high, and it's expected to get this result for Brasilia. So that's my last slide. I can't see a clock, but I think it's about time. So, like I said, I chose this policy design of optimal and non-optimal based on only 2 indicators. There are 66 other indicators, so there is a lot of room to use policy space 2 as a study case, an object for us to investigate this inverse generative social science, right? Because we know the theory, we know the model, the code is public and transparent. You can go there, download, GitHub, change, evaluate. I don't like this rule, change the rule and do what you want, right? We can vary the distribution of configuration parameters. I used the truncated 3 sigma distribution, then I used normal, but we could use uniform and other distributions and check. We could use other machine learning algorithms that I'm not familiar with, genetic algorithm and neural networks, and see what happens. We can enrich the original sample. Now that we have this job, we can change, for example, I'm running more cities. So I have more information to get this result of the cities that got me curious. And then we can work with a 10,000 sample and generate 10 million sample and see what happens, right? And this one, I don't know, maybe somebody will email me tomorrow, how to test a parameter that is not in my model, something that I didn't think about, but I have past data. I could use that past data to inform me what is missing in the model. And so that's about that. The preprint is here. I sent the PowerPoint to Bill. I again thank you very much for the opportunity to listen to Scott Page and Rob and Josh and Bill. It's wonderful, and Ivan and Gururate and everybody. Thank you very much, and I hope I have contributed a little bit. Thank you.
Thank you very much for that, Bernardo. So we do have a few minutes for questions and answers, or questions, maybe some answers, depending on if there are any out there. So let's see any hands right now. So Bernardo, while they're working, you and I have talked a little bit about this before, but to what extent is policy space like at what point do you think it'll actually be usable to inform actual policy decisions, right? Do you feel like you're at that stage yet where you could go to a minister and brief them on the results from policy space, or do you think it needs more effort than that at this point?
I'm getting there, Rand, Bill. Matthew asked this exact same question last year, right? And I come from urban economics, right? I'm an architect. I did geography and then economics. I'm not a computational scientist, but from the urban economics and from the urban policy background, it informed me that housing policy alone might not be the answer, right? For Brazil, the numbers are staggering. Like I said, you need to give 54,000, you need 54% of the population don't have enough income to buy a household or to rent. And this is actually a problem. But as a government, you cannot also build 100 million houses, right? I just put in the reviewer for my paper that do you know about Minha Casa Minha Vida, right? Which translates for My House, My Life, which is the Dilma Rousseff's housing program. It was incredible, unprecedented in Brazil, and it built 6 million houses in a period of 10 days. Houses that are far away, houses that are not serviced with education and jobs and everything. And the housing deficit inadequacy remained at 6 million throughout the period, right? So it might not be the case that housing policy will solve the problem eventually. So for me, it was very important to say, okay, I'm an urban economist, but the decision for this policy might be in other ministries. So providing income and valuing jobs might be more relevant for the housing than the housing policy itself. So I learned it. The validation is very detailed, and I do hope that this understanding of where lies the most important thing helps governments.
That's great. That's great. Yeah, that sounds fantastic. Any other questions out there? Okay, well, maybe if there's no other questions, we can move on to the final talk of this session,